Okay, in this problem, we're considering the experiment of flipping a coin 3 consecutive times. So it's the same thing happening 3 times in a row. Now, we want the probability of each of these events. Number 1 is the probability of 2 tails. So recall the definition of probability. If we want the probability of 2 tails, we need to count 2 things: the number of ways 2 tails can happen and the total number of ways our experiment could play out. So to do this, I'm going to actually list everything in the sample space. And to do this, let's consider one flip at a time. So let's say flip number 1, we have 2 options. Flip number 1 could result in heads, or flip number 1 can result in tails. And flip number 2, same thing. The heads could be followed by heads, and the heads could be followed by tails. Same thing if the first flip is tails, could be followed by heads or tails. Flip number 3, same thing, followed by heads or tails, heads or tails, heads, tails, heads and tails. So when we're constructing the sample space, and again, this is one method for constructing the sample space. I like it because it's visual, but it doesn't work very well if there's many more trials or many more options here. But so using this tree diagram, what we do is we trace the tree, every possible path on the tree going from left to right. So this first path, heads, then heads, then heads. So that's one possible sequence of 3 coin flips: heads, heads, and heads. The second one, heads, heads, tails, that will put us at heads, heads, tails. Ending here, heads, tails, heads. Heads, tails, heads. Down here, heads, tails, and tails. And just keep repeating the process till we exhaust all possible paths. Tails, heads, heads. Ending here would be tails, heads, and tails. Ending here, tails, tails, heads. And finally, tails, tails, and tails. Okay, so problem number 1, what's the probability of 2 tails? Well, we have our sample space. This is what we have in black on the right. We have our sample space, so now we just count the number of outcomes that are that correspond to this event. So then the event is 2 tails. So let's use green here. How many of these events have 2 tails? Well, there's one, and there's one. So out of the 8 total outcomes in our sample space, 3 of those outcomes have exactly 2 tails. So the probability of 2 tails should be 3 out of 8. Number 2, at least 1 tail. So at least 1 tail means what? 1 or more. So 1 or 2 or 3. So at least 1 tail looks like all of this. All 7 of these have at least 1 tail, 1 or 2 or 3. So probability of at least 1 tail should be 7 out of 8. The number of ways this could happen divided by the total number of outcomes of your experiment. And finally, at most 1 tail. So that means 1 or less. So 1 tail, and 1 tail, or no tails. So let's see, those 4. So we want to give this as a reduced fraction. So 4 out of the 8 outcomes in the sample space, or reduced fraction, we could say 1/2. So 3/8, 7/8, and 1/2. That about does it for this problem.